Hi everyone, today we're going to be talking about permutation, so let's get started. Now that you can find the total number of outcomes using the counting principle, we will talk about what happens today if you have a situation in which order can affect the total number of outcomes. A permutation is an arrangement of objects in which order is important. For example, if you were to win first place, it's kind of a big deal. Second place is second best, third place is almost there. Alright, let's look at it. It says without replacement. What that means is don't use them up again. All right. How many ways can you arrange the letters Y, T, and R into 3 slots if each letter can only be used once? So since we have 3 letters and the letters are Y, T, and R, I prepare myself for 3 spaces. And then what I do is I ask myself, well, for the first space, how many letters do I have to choose from? I have 3 letters I can choose from. Once I choose one letter, let's say I chose Y, now for the second space, I have only 2 letters I can choose from between T and R. Once I use one of those letters, now I only have one letter that I can choose from, and that could be R. So the product of these options kind of gives us how many total options there were. So 3 times 2 is 6, times 1 is 6. So we really have 6 different ways we can arrange the letters Y, T, and R. Alright, now let's look at that once again. It says how many ways can you arrange the letters X, C, V, B, and N into 5 slots. So I have 1, 2, 3, 4, 5 spaces. Well, I have 5 letters to select from for the first space. Once I pick one, let's say we do C, now I have 4 letters I can pick from. Once we pick another letter, now we have 3 letters I can pick from, and 2, and then 1. So it decreases every time. I'm going to type this in really quick to my calculator, and we have 120 different ways. All right. Now let's look at it when it says with replacement. What that means is you can use each letter more than once. So no repeating for where did it go? No. There we go. And then for with replacement, sorry, my computer's acting up. There we go. With replacement, we means you can put it back. Can use again. Okay? So it says how many ways can you arrange the letters W, E, and R? So here are my letters. And I have 3 slots again. So I'm going to do 1, 2, 3. It says if each letter can be used more than once. Alright. So for the first space, I have 3 letters. Let's say I use W. The thing is I can use it again. So for the second space, I have 3 options as well. And let's say I use W again, well, I can use it again, and therefore I have 3 spaces for the last one. So I'm not taking any of these letters out of the bag if I had them in a bag. Okay? So 3 times 3 times 3 is 27. So it's 27 different ways. Alright, now it says how many ways can you arrange the letters W, T, Y, U, P into 3 slots if each letter can be used more than once. Alright, so our letters are W, T, Y, U, P. But this time I have 3 slots. 1, 2, 3. So you don't always have to have the same number of slots as the number of letters that you have. And it says you can use the letters more than once. So for the first slot, I have 1, 2, 3, 4, 5 letter options. And since I can use them again, I have 5 for the second spot and 5 for the third one, making that 125 different ways. Easy peasy? Lemon squeezy. Alright, let's go ahead and look at the next part. So it says here in this problem, Joanna always takes 4 items to school for her lunch: a cheese sandwich, a box of raisins, a can of juice, and a banana. Sounds like a pretty healthy lunch. Notice the difference in the problem below. Assuming she doesn't care what order she eats her food in how many different ways can she eat her 4 items? Alright, so she has 4 items and she's eating all of them. So I'm going to have 4 different spaces. We have a cheese sandwich, item number 1, a box of raisins, item number 2, a can of juice, item number 3, and a banana. That's 4. So we have 4 options she can choose from. Okay? Now, let's say she chose to eat a banana. Well, if she eats the banana, now she has 3 options left for the second spot. And then once she chooses something, let's say she drank her can of juice, well, now she has 2 options. And then let's say she ate her cheese sandwich last, and then now she has only 1 option, which is a box of raisins for the last spot. So the product of that gives us all the different ways that she can change up her lunch. So there's 24 different ways. All right, now, how many possible outcomes are there if she wants to save her juice for last? So imagine that I have this 4 spots. I have 4 things I want to eat, but I want the last one to be the juice. No questions asked. So that's only 1 option there. Okay? So if I want the juice to be the last one, the question is, how many options do I have for the first space? Well, I only have a cheese sandwich, a box of raisins, and a banana. So that leaves me with only 3 options there. And then I have 2 and 1 as I eat them. And the 1 for the last one is the juice. There are no options there. So that limits me to 6 different ways. So the pickier I am, the less options that I have. All right? I hope that was helpful. All right, let's look at a couple other ones. I think we have 2 more problems we got to do. So let's look at this one. It says 35 people are in your class, of which 15 are males. How many ways can you elect 1 male and 1 female representative? So I'm going to elect 2 people. 1 is going to be a male and 1 is going to be a female. So what I want to know is, how many do I have of each? Well, for the males, we have 15, and they're very clear about that. They say we have 15 males. Since we have a total of 35 people, that means the rest of them are females. So that leaves us with 20, creating that total of 35. So how many options do I have from selecting a male? Well, I have 15 people I can choose from. And how many options do I have for selecting a female? Well, I have 20. So 15 times 20 gives us our 300. So that's 300 different ways I can actually go ahead and simplify this expression, or have different outcomes. It's pretty cool. Now, license plates that we have in our cars also work the same way. So if a license plate consists of 3 letters followed by 3 numbers, notice the difference, okay? So, by the way, there's 26 letters in our alphabet. That's important to know. And there are 10 numbers. The numbers go from 0 to 9. So that's where the 10 comes from, okay? How many different plates can be created without duplicating numbers or letters? So we are not using them again. No duplications. All right, so we have 3 letters, letter, then 3 numbers, number. I'm just going to put an L representing letter and number symbol representing the numbers, okay? Now, they don't want us to duplicate, so once I use a letter, I cannot use it again, all right? So how many letters do I have? Well, we have 26 letters. Once I use one of the letters and I can't use it again, now I have 25 letters. And once I use that one, I now have 24 to choose from. So that's how the letters will work. Numbers are very similar as well. Well, I have 10 numbers, 0 to 9. Once I use one of them, I can't use it again, so I have 1 less, making it 9 options for there, and then 8 options for the last one. And the product of those, 26 times 25 times 24 times 10 times 9 times 8, gives us our final possibilities. 11,232,000 options. And that's why we don't have any repetition of license plates, because we need as many options as possible so everyone is identified differently. All right. Now, how many can be created if you can duplicate numbers or letters? Well, if I have 3 letters, again, letter, and then I have 3 numbers, number, and I can duplicate. That means I have 26 letters to choose from. And if I choose one, I get to put it back in the bag. So I have 26 again for the second spot and 26 for the third one. So I'm not losing a letter because they're saying, hey, you can use it again. And then I have 10 options for numbers, 10 again, and 10 again, because once again, I can use any of the numbers that I've received. So it's 26 times 10 times 10 times 10, 26 times, all that. So we have 17,576,000 options. So the less picky I become, the more options I end up getting. Okay? So that is all the problems that I have for you for today. This is called permutation. Well done. Well done. I can't wait to see you in class and do some more practice problems with you. Have a wonderful day.